Hi, class. So, as you saw in Chapter 1 of Sleep Science, our brains cycle through several different stages of sleep, from light to REM sleep to deep sleep. So, I just kind of want to quickly review. Sleep is broken up into multiple stages, which differs from each other based on eye movement, heart rate, brain waves, body temperature, and other physical signs. The first stage of sleep is called stage N1. This is a form of non-REM, and it is a very light sleep stage where you may still feel half awake. After N1, our brains go into N2 sleep, which is still a light non-REM sleep, but you feel fully asleep at this point, and it becomes harder to wake you up from stage N2 sleep. Next, your brain enters N3, also called slow wave sleep. This is the last non-REM sleep stage. Sure, I know that illustration that you saw, and hopefully you reviewed that, even described stage 4. We kind of like dropped away from using stage 4, noting that N3 and N4, both neurologically, physiologically, were the same thing. Anyway, as I just said, N3 is the deepest stage of sleep. And in this stage, it is very, very hard to wake someone up. And your brain is doing lots of hard work, storing energy for the next day and processing memories from the day before. I suppose I could go on with what's in the text, but I think a relatively brief video presentation that covers sleep stages and circadian rhythms in a helpful illustrative way will reinforce the reading material and what I say here. So look for that in the folder. So let's talk a little bit about circadian rhythms. Okay? And that is also defined in that video presentations. Circadian rhythms are actually quite complicated and depend on a number of different factors. First, your body's natural production of melatonin plays a huge role when you start to get sleepy. Now, if my memory serves, one of you mentioned that you tried melatonin but was disappointed in its effects. A word about melatonin. For most of us, its very production increases in the evening and reaches its peak in the very early morning. But just as an aside, for people with delayed sleep phase syndrome, melatonin production may be behind schedule by 2 hours or more. No worries, we'll deal with melatonin later. And by the way, sunlight also plays an important role in our natural circadian rhythms, which is why moving to an area near the North or South Pole could mess with your sleep patterns. These areas tend to have months of extra sunlight or practically no sunlight, which can throw a real wrench in your internal clock. You also experience circadian rhythm disruptions when you travel across time zones. Oh, a hint. One helpful thing that you can do is to get exposure to daylight at your destination as soon as possible. Even setting our daylight savings time to standard and reverse, which by the way is right around the corner, can be mildly disruptive. In fact, with regard to our own little 1-hour shifts, research has shown that moving our time ahead 1 hour has more of an unfavorable effect than moving it back. No wonder I love California and in particular San Francisco. Pushing the clock back 3 hours is easier than pushing it forward. If you've ever traveled to Europe or simply east of the US, your circadian system can be pressed with 5 hours or more. Yikes. Again, get out into the sunlight as soon as possible and force your brain to adapt as quickly as possible. Melatonin can help, but more on that later. A collective question that seemed to have emerged from your first discussion board topic: how much sleep do we need? I was not surprised at the variation that many of you reported in the number of hours you felt you need every night, nor was I surprised at the fact that so many of you already recognize that you are simply not getting enough of it. Odds are you know that you're supposed to get 8 hours of sleep, each night. Some of you stated that. But did you know that it isn't true for everyone? For instance, we know that babies need far more than 8 hours sleep, and older adults actually need a little less sleep. These differences are largely due to differences in circadian rhythms. Babies don't have set circadian rhythms at birth and instead tend to sleep in several chunks throughout the day, known as polyphasic sleep. Seniors experience a phase shift in their circadian rhythms, causing them to get sleepy earlier and wake earlier than they did when they were younger. If you notice that you tend to feel you're most alert and awake after only getting 6 hours of sleep, or if you find that you experience daytime sleepiness anytime you get less than 10 hours of sleep, you may be one of those exceptions to the 8-hour rule. And hopefully, maybe that's a matter of self-discovery when you really start to take a much, much closer look at your sleep cycles or sleep staging. By the way, approximately 6 to 10% of people need more than 8 hours of sleep each night, while around 5% of people actually function better with a little less than 8 hours of sleep. Is that you? You're going to find out. Everyone is different, but we all still need a good amount of sleep. Well, what happens when you don't sleep? Well, many of you already know what that is. It's got very serious repercussions, both in the short term and the long term. And so if I could summarily say, short-term sleep deprivation can cause sleepiness, distractibility, and lack of focus. And these things can be deadly. Studies show that driving tired is just as bad as driving with a blood alcohol content, BAC, of 0.10, which is about 1 drink over the legal limit. And even though a term sleep debt, which we will explore later on, makes it sound like you could make up for your sleep deprivation by simply getting more sleep later, it doesn't really work that way. There are long-term issues with missing out on quality sleep as well. Long-term sleep deprivation can have serious consequences for your health. Lack of sleep can lead to heart disease, decreased immune system function, and weight gain. So whenever you can, try to get enough sleep. Well, that's in part of why you took this class, right? Is to explore your sleep and see how you could tweak it to make favorable improvements. Anyway, I just want to sort of like as an aside, I guess maybe to whet your appetite about the other material that's going to follow. We know what sleep is, but what about when sleep goes wrong? Sometimes we may experience brief sleep disturbance, but other times our sleep problems become a real issue and may qualify as an actual sleep disorder. And I know many of you, some in your introductions, had expressed a keen interest on them. So I'm just going to again whet your appetite with it. We're going to be exploring delayed sleep phase syndrome. This is when a person's natural circadian rhythm doesn't encourage sleepiness until much later than normal. We're going to talk about insomnia, and you remember in my introductory presentation, I said that was the number one sleep disorder, and a few of you reported that you experience insomnia. But we'll talk about narcolepsy, obstructive sleep apnea, restless leg syndrome, sleep paralysis, sleepwalking. A few of you had described sleepwalking episodes. My sister, by the way, is a habitual sleep talker. Anyway, what I want to kind of mention here to just give you a broader perspective about it, that there are sort of like 3 prominent theories as to why we sleep. There's a theory, sleep for survival, and according to the theory, people and animals need sleep because it protects them from danger in some way. The theory suggests that we sleep during the hours that are most dangerous in order to avoid attracting predators with movement and noise. This is an evolutionary theoretical basis of why we sleep. However, theory doesn't explain everything, like why we're so defenseless when we sleep, right? Or why some high-ranking predators with few threats to worry about, like lions and humans, sleep much long hours, right? Another theory is we sleep for growth. Theory says that we sleep because it helps us grow, especially slow wave sleep, and the evidence for that is mounting. Studies show that children and athletes spend more time in slow wave sleep than older adults, suggesting that more slow wave sleep is necessary for cell regeneration and repair. And then also there is sleep for memory processing. This last sleep theory suggests that sleep exists to help us process our memories. And there is a lot of science to back that up. A good night's sleep has been linked to better procedural memory, which is a form of implicit memory. And it also contributes to better declarative memory, which is a memory of facts and events. And sleep seems to play an important role in helping us transfer information from short-term memory to long-term memory. So you see, sleeping is not just a shutting down of the brain. Very, very delicate neurological dance is taking place between various brain structures and clearly behavioral consequences of these different brain structures. Anyway, let me just say a few words on dreaming. Many of you expressed intense interest in them, and we will cover dreams in greater detail. But according to our best theories, dreams could be a completely random collection of images caused by random firings in our brains as we sleep, or like sleep itself. They could help us process and store our memories. Other scientists suggest dreams are meant to help us survive by simulating threatening situations so we can unconsciously prepare for them in case they happen in real life. The truth might be a combination of these theories, but frankly, it may be none of them at all. So just to broadly summarize, our nightly sleep is made up of several sleep cycles, each of which is composed of different sleep stages, and the physiological and neurological differences between two modes of sleep, rapid eye movement and non-REM, are almost as profound as the differences between sleep and wakefulness. Okay, I hope you enjoyed this video presentation. I hope it wasn't too long.